Hello guys. So here is the final comp of our decloaking effect, and hopefully you managed to follow along okay with the pretty extensive comping that we had to do to get this to work. But I think everything went surprisingly smoothly. I've only made a few tweaks since the last time we worked on this comp, and I'll take you through that now in the recap. But for now, we're just watching the final result, and obviously this shot will continue to extend past this point for the second effect in this shot, which will be the last effect of this workshop. So before we head into week 7 and 8 to work on the last effect, let's recap quickly the Houdini scene first, and then I'll jump back over here to the comp and we can go through the comp as well. So jumping back to our Houdini scene, we had this basic drone cache over here. So let me make this bigger so we can just cover everything. If we look at this, we had this drone cache and it's got a pretty busy mesh. So first order of business was to tackle making some kind of uniform geometry that we could make a better propagation for. So once again, as with the rest of my effects, I've kind of done some base setup at the start and then this basic propagation network here, and everything else after that was based on that propagation. So if we just have a look, a lot of this also requires moving to the rest position and maintaining some kind of attribute which tells us where the animated position was. So in this case we actually used animp and p equals rest quite a lot to move points and geometry back and forth from the origin to the animation point. So here we just used BDB to generate a solid mesh, and we raid that back on and then remesh that to generate a good level of detail for our hexagons later on. So that's basically just generating a clean mesh from our animated cache. We move that all back into position, and that's where we moved on from there. Here is a basic workflow for propagation, which is basically keeping 2 points, transferring the color from those 2 points back onto the mesh inside a SOP solver. So I won't run that, but I have it saved out here. On top of that, obviously we added this noise onto the point cloud to make the propagation look slightly noisy as well. So that's the result of the propagation there. And you can see once we move this back into position, which I'm getting ahead of myself because we took that propagation and here we generated a leading edge. So simply taking the propagation, moving it back a frame, keeping that, transferring it back on as black, then we left with a white line. So then we had a pretty cool looking leading edge for our base effect. And from there I emitted particles, moved everything back to the animation position, and we ended up with a pop sim that covered all the bases for the rest of our effect. So it moved in the animation position, it traveled along with our propagation, it had age, so everything we need. And we ended up using that in a lot of places. You can see here we have the source for our electric arcs, and then obviously there's converting the clean mesh over here into hexagons. Then we simply use that point cloud to drive some basic hexagon motion over here. So loads of room for you guys to experiment with other options of deforming this mesh. In this case, I've just taken the hexagons and one of my deformations was a rotation. So if we look at this, you should be able to see some areas where you can see them rotate. It's pretty subtle. For the most part we see the displacement, but there's definitely some rotation happening. The displacement one over here. And there's a million ways you could apply a deformation here, as well as ways to mix it with this mask. So we have a pretty nice clean contrasty mask over here, and we're just basically mixing all those layers of deformation based on our color ramps, our ramps over here, and that mask input. Then the final displace, just to make sure it sits outside of our drone cache. And then on the other side of this network, all we did was we took the original drone and transferred the color from our propagation onto it, so that in the shader we could use that to output an extra image plane to use in comp. So that's pretty much the basis of our effect here, which is pretty simple. And if we jump out, some of the more interesting things that happen are in these other geos. So for one, we have the hexagon mesh being called out, and nothing fancy happening there, except we decided to branch off and add our projection lines. So a pretty simple setup here as well. I don't think it took more than 10 minutes. And that was getting the drone, keeping just the core, copying some lines onto our hexagons, and raying the other end of the line to the core. And that gave us some interesting lines, and we added another noise in here as well. So very simple but effective on that front. In terms of shaders for both, we didn't do anything crazy, but there was some pretty interesting emission layers we added. For the drone itself, For the drone, we have some noise moving through a few ramps that are determined by curvature. So we tried to highlight the edges, and I have a noise running through those highlighted edges there. And then we have another occlusion, which is basically selecting the insides of this drone that should be occluded, and I'm just using that as a mask to multiply one of those edge outlines. That just goes into emission, nothing else going on. And back into our hex deform shader, and it's pretty much the same, but we have used this wire pattern to make sure we get an outline for each one of those hexagons, and I think we've used that pretty effectively in the comp as well. So you can just see those hexagon outlines there. And this line is just calling in the lines and applying a basic emission shader to it. And then a slightly more complicated setup here for our electricity. So we can ignore that. That's the initial burst from the drone's core. But the most important parts were making sure we understood what would make a convincing electrical effect, which is basically, for me, not adding too much moving noise, but instead relying on animating the amplitude and the length of the line as well. So if we take a closer look, we use the particles directly from the propagation setup, deleted most of them, copied some lines randomly, but based their length on the age of the particles, and then a combination of raying, mixing positions, raying again, resampling for enough detail, a combination of different noises mixed together with color, alpha, and amplitude being driven by the age of their initial particles. Transferring the position from the drone back onto the arcs to make sure we have a good connection and a polywire at the end. Then simply took that final arc setup, kept only the brightest ones, took some source points and transferred them onto those arcs and generated small little lines to be our branching. Copied and pasted a few of those nodes from this side over here, merged them together, and we have a bunch of arcs with a bunch of branches as well. And I think that worked very nicely. And we're outputting the same thing here for the geolight, and that's just a basic geolight, no additional settings here. We just had a physically correct fall off, and we're looking at the arc itself. Pretty high samples on that, and a basic emission shader as well. And that's it. Rendered all these out as separate layers and kept the arc light as a separate layer as well. So if we jump back over to the comp, let's look at this one more time. We can see some of those things we were just looking at. So the deformation on the hexagons, quite visible. The extra detail we added in the shader as an emission pass. A little bit of color on the hexagons as well. If you see, the leading edge is slightly brighter than the back edge, and we have those outlines. And then obviously the inner projection lines as well, and the arcs. So altogether, pretty happy with that. And if we just have a look at the comp itself, it's a bit of a jumble. And it's very difficult to run through this kind of comp afterwards, but if you follow it along, the basics of it were to make sure that we used our mask, which was this simple black and white render here. So we just needed to make sure we generated a good mask that we could subtract the whole underlying drone based on that mask. So we rebuilt the drone so we could affect the emission separately, and then we just subtract the drone using that mask. Down here we combined some of the hexagon layers to make that look as good as possible, and then just merged that on top. So we see the hexagons, and underneath the hexagons we see the actual drone coming into existence. And then for a few reasons I've set a different track over here for what becomes our glowing geometry, just to manage things like highlights, really. Because if we look at the drone, there's a lot of highlights here that I don't necessarily want to glow. So I basically tried to keep emissive objects as a separate track. And so only the emissive objects glow. Then a few little things we had to plug in along the way. So that's our arcs, our lighting from the arcs. We just merged those on top, and our projection lines. So no fancy comp tricks there. And that's how that all looks together. And then a very basic setup here just to defocus the background where the drone is, merge in a little bit of light and a little bit of reflections, and then displace it on X and Y using the normal pass. So it's a fake refraction with a little bit of light. And then we merge the rest of the drone on top. And I did go and I set some keys on one or two of these layers. You can see over here, this is our arc lighting layer. So it has that initial anticipation effect. And I just color corrected that. So it's a much brighter at the start and then fades back to normal. So if you look here, it starts at 50 gain, and just goes down to normal. And that has a green line because I'm referencing that color corrector and applying it to the same render layer, but the one that we're merging onto the drone itself. And that's it. So I hope you guys enjoyed this effect, and I hope you can do something interesting with it that I haven't thought of, or just take it in your own direction. Especially if you're using something other than this drone itself. If you find another piece of geometry like a spaceship or a car or something else, I'm interested to see what people can come up with. So let's end this here, and I will see you guys in week 7. So see you then.